Hello, it's Thursday again. I came around quick, so it must be time for more live coding with Haskell. So in the last session, I started off trying to add a result type to the pipeline so that functions inside the pipeline could effectively return errors and we could pass those errors along the pipe. But when I started to write it, I got in a bit of a mess because the interpreter now was trying to do type checking and also handle this slightly more complex type within the pipeline itself, and that was just difficult to write. So I stopped and I extracted out the type checking, so that happens first, effectively a static phase before we run the pipeline, and then in the interpreter we just run the pipeline and handle we evaluate the functions inside that, pass the result along. Now I was going to go back and look at the result type, and I still plan on doing that, but it might be next week now, because something annoyed me at the end of last week, which is this, all of the functions in the pipeline are built-in functions, and I ended up defining them twice, once in the type checker to list out all of the built-in types and give their type, I guess, all the built-in functions, sorry, and give their type, and then I define them again in the interpreter so that we can evaluate them. And I want to combine them. So we have one definition of functions, and that includes information about the name of the function, so we can call it, the type of the function, so we can type check it, I guess, and then the actual implementation, so we can run it. Yeah, so that's what I'm going to start with today. If I get that finished, I'll go back and start looking at result types as well. So pick up from last week. In the interpreter, I sent a wave. I didn't wave properly. There we go. I meant to save a wave emoji in the chat, but I forgot. Okay, so in the interpreter itself, we have this type check because we can't write type because that was clashing with Haskell's type. But in the checking the built-in, you can see here we have to define the type of UID and the type of strip and the type of parse time. And in the evaluator, we again define these functions. I don't really like that. So what I want to do is build a list of functions which have got the type and has implementation. And I think it's just going to be a map between the name of the function and then probably some record that contains its type and its implementation. I think we know the type of implementation because the implementation is always a function that goes from an expression to an eval result. I can check actually, it'd be down in here. Yeah, that's the type of all of the built-ins. Or is it actually, do they go? No, maybe break it up a little bit more. And we'll say it goes from a list of arguments and an input value to an eval result. That's probably the correct type for the function. Okay, so I think I'll do in here. I'm a little bit worried about splitting it to its own file because we might get some pain of circular imports. Or should I take the pain now and just tidy this up a bit? I'll start running it. Maybe I can move it later. So the thing inside the map, so the definition of a function, I think, is going to be a record, and we will have a type, a pipe. So the function pipe, which is a type pipe, and we will have function definition. Definition, which is of type, I guess something like function signature. So what's function signature? Function signature, it needs to be capital because it's a type. Function signature is just an alias for list of text, which is the argument list. to a value, which is the input, and it returns an eval result. Like that. Okay, and then we can say something like functions, I guess, just define this. Functions is going to be a map from text, which is the name of the function, going to the definition of a function. And how do we create a new map? I think I might want to use from list here, but I'm not sure. Let me just find a browser. Google, that's what we want. So from list. Is there some kind of thing in map? Something in containers, ideally. Data.map from list. I think this is what I want. So it's a list of pairs with key and value. Okay, I think that's what I'm going to use. I'll try it anyway. So it should be m dot from list. Just import m. So we want. Oh, this doesn't scroll properly. Data map. Do I want to be strict or lazy? I honestly don't know. I'm going to put it qualified as well. Oh. Why is it not going to do that for me? Import data.map.lazy, oops, qualified as m. Okay, so we're going to call m.from list, and then we're going to give it our list. So the first thing in the list is going to be a map from our first function, which is UUID, and then it's going to be a function where the height is void. I think it's going to scroll down and check that, but I'm pretty sure that takes void somewhere. Can we get to it? This file is getting too long. Yeah, so this goes from void, and then the definition of the function I should probably split out. So function definition is something, it's going to be some function, so it's going to be, let's call it eval UUID. And save it. Okay. So void is not void, is it? It's void height. I need to write eval UID. So eval UID, I said it's going to take the arguments, so it's a list of text. It's going to take a value, and then it's going to turn the eval result. And it doesn't care about the input value or the list of arguments. So we just ignore those, and we'll just say it's equals statically 1, 2, 3, 4, 6. It does. And this should be just that. No, not just that, pure that. Okay, and I'm guessing I have to do this for all of the things. So what else do we have? Let's go and grab a list of the functions, I guess. That's probably the bit I really want. Let's paste in there. So we can say eval strip, I guess. And that's of type text. Can't use function signature. Sorry, I've just noticed a comment in chat. What do you mean can't use function signature? Don't know what that chat comment means. It might be out of date already. Can't use functions for eval AD. Oh, yes, of course. You can set a function signature. That saves me a lot of repeating stuff. Thank you. So function signature. Cool. So eval strip. Here we do care about something in the input. And we want a text value of v, and that's going to be pure text value of t dot replace x with empty string like v. Should this be pure of text value? I wonder, actually. I think it should be that. And then eval parse time. So eval parse time. Let's just do with this that, and it does take an argument. Sorry, I should have deleted that first line. How does this work? Parse time takes an argument, doesn't care about the input value. So again, this should be x and one of those. And I wonder so these are not exhaustive because that all seems right. Eval parse time of anything else. It's an argument error. Do we have an argument error? Running command. Those are the only two we have. So let's go argument error. To name a function that has the error, I guess the number of arguments that it expected, the number it got. Say show argument error. Name of the command, the expected and actual, and it should be expected actually we'll say when calling a wrong number of arguments. Let's do that. Wrong number of arguments when calling. Center that a bit, right? When calling quote C expected show E. Forgot his space is random. This is terrible at building strings. Got that many. Okay. So we have argument error now. So up here, we can have these are the args. So we can say something like left of argument error, and this is eval. It's parse time, and it expected 1, and it got length of args. How many lengths have we got now? Why is it imported twice? So we import qualified. That was why. Ooh, I didn't really do it like that to import this qualified as something. That might be new. Okay. And then we do a similar thing here. So eval strip of args and nothing is left argument error eval strip expected 1 got length of args. Okay, and then I can fill in my function definitions here. So eval EUID, and it's a function. It's run like this. So it's a function which takes text value, text height, and it also takes eval strip. Yep, I might just write them like that because it's slightly shorter. Okay, and then we have, why did I write EUID there? That should say strip. And this is parse time, and it's a function which takes void and returns eval parse time. Okay, so we've got our list of functions. Can we now use them in the type checker? And then when that works, can we use them in eval? Okay, so the pite checker, sorry. So this check built-in type, it's got the name of the function, the type that it's given, and the type that and the result is in the type check. So the type that it produces. Okay. So what we're going to do is we want to look up in the function, in the list of functions, sorry. What have we got? We've got name, and we got height. And here we can say m.lookup. I'm going to look up the name in our function list. So what are we going to do here? We're going to say case this of nothing. We've got two cases, right? We've got just, and then we get our function back. So this is going to function where we only want to extract the function type, function pite. Come back to that in a second. And then we've got nothing. And in the case of nothing, we haven't found a function. So this is going to be left of, oops, left of unrecognized command and the name of the command. Okay. And then in here, you can say check pipe matches. So we expect function pipe, and we're given p. So definition of check pipe matches. This is going to have to go from pipe to pipe to pipe check result. And we can say, oh, thought it filled in for me. Probably because I got errors in my file. So check pipe matches of expected and actual is if expected equal to actual, then we're good. So then this is pure P or pure expected. It doesn't matter because it should be the same. Else left of incorrect pipe C expected and actual. But C is we need to name. That's a bit annoying. So text to that. So this is the name of the function, the thing we're calling. Give me that. Okay, I'm looking wrong here, so couldn't match pipe to pipe check result. I need to put the name in, don't I? So the name of this thing is, oh, we have it, the variable name. There we go. So that should now be my pipe checker. In the spec, have we got specs for type checking? We do not. Okay. And also we've got an error somewhere. That shouldn't have said too much. Is that right? Filter on Cabal. Function definition is not used. Okay, we could probably rewrite eval. So call built-in's got this signature, and it's going to be very similar to the pipe checker. So call built-in given some name, some args, and some value. And what it's going to do is going to say again case m dot lookup name inside the functions of just function, and here we only care about the function definition. And given function definition, we can say we just run it, don't we? Function definition args and b, and then nothing. We should be able to say left unrecognized command and then the name, and then we just ditch those. Okay, and that should be it, I think. First of all, let's see if Cabal runs. It did not run. Okay, so let's look at this. So eval seems to work okay, but run does not. I'm guessing the type checker doesn't work. Is okay. Okay, so expected left function is not taking the arguments, but it actually just worked. So the type checker doesn't seem to work at all. Which is interesting. So inside run, there's a pipe check of expression. I think it's an error, it just turns the error. Okay, so the expression starts with void. Okay, and P is the previous type. So we've got the name of the function here, the previous type, and then some result. So we look it up, and then we say, check that the expected type matches the type that's passed in. Oh, okay. We're returning the type that's passed in here. So if the type's check out, so if it expects void and you call it void, then it turns the input type rather than the output type. So in our definition function, we got we're going to have an input type. Can we rename that? Does this work? Let's find out. Function input pipe, and then we got a function result type pipe. Again, is a pipe. Right. So UID takes a void type and it returns a text pipe. Strip goes from text to text. And parse time goes from void to time pipe, I think it is. Okay. And now we're doing the type checking. This file's too big now. We're going to pipe checking, sorry. So it goes from name of the function, the expected type, to the result, and we're going to extract from here the function result type, result pipe. And I might just write this in line because passing pipe into something gets a bit messy, I think. And it's quite short, so you can say if the function input pipe is equal to the type we've been given, then but it's going to be the function result pipe here. Else, type it in there. Else it's left of incorrect pipe. The name of the function, expected, and the actual. So expected here is function input pipe, and the actual is B. And then I get rid of this. Okay, does that work? Yay! Okay, cool. 30 minutes, that's not bad. So we have now moved our list of functions into a single place, and then we call them from the type checker, and then we also use them when evaluating. And it makes the definitions of type check and eval a lot shorter. Cool, okay. So let's commit that, I think. And stays up. So what's in here? This is, what have we done here? This is just refactoring inside the interpreter. We haven't changed anything else. So this is centralize the built-in function definitions. Okay, push upstream. Right. Back to where we were. So I think I'm in two minds. I think I would like to break this file up a bit because it's 100 lines long, terribly long. Maybe that's not so bad. I want to change the definition of eval. There's quite a lot happening in this file. Let's just keep going. So inside eval, I want to introduce the idea of creating a result type and returning that from every command in the pipeline. And then when something gets a previous error, it stops. It doesn't stop, but it just doesn't evaluate it, and it just passes the error forward. So it stops evaluating it first error. So let's restart the LSP server so it stops complaining about stuff. Is it done? Yep, cool. Where's my warning? Oh, stupid file. Okay. So what are we going to do? Describe errors, I think. And so here, so we'll say something like it's stops processing when encountering an error. And I'm just going to set it undefined for a second because I need to think about, I need a function that returns an error. Oh, I think I had this before. Okay. So parse time, if you give it something that's not valid, we expect that to return an error. Okay, so we can just use this. So we can run parse time, but we're going to give it something invalid. And I'm going to get rid of the next stage in the pipeline. So maybe actually it's not that it stops processing, but it returns an error. Errors can be returned from functions. So we'll call parse time with nonsense. And then this should be something like maybe something like error when calling this is parse time. And then we want to put in the actual error that we get back. I don't know what that is. Something like invalid time. typo there, it's annoying. Okay, let's run that test. Okay, on call exception, error call, parse time error, bad time format. So I think we're just calling error at some point, but it's bad time format. Is that an error I've created, or is it something that comes back from parsing the time? No, it's something I'm doing. Okay. So I could say this, invalid time format. This is what I want to happen. So my function signature says I'm going to return an eval result, and an eval result is either an error or a value. And I think I want to change this to be either an error or a result. So result, oops, data was it okay an error? I think that was the Rust form. So okay has then got a value or error, and it's going to just be text, I think, for now. It's the only thing I'll support. Okay, so then I need to change everything, but these are basically wrong now. So it's going to be pure of okay of that. This is going to be pure of okay of that. And down here, this is going to be pure. Okay, I need to move my pure a little bit. So this is going to be pure of okay of that, oops, of that, and this is going to be error. Actually, I don't want to move my pure because the pure is applying to the evaluation of whether or not that call can be violated, not the result of that call. Okay, so I can get rid of the pure down here. So either it's okay in a time value or it's an error, and the text was going to be something like, well, it said here, error when calling. When calling, and this is called parse time. And it's invalid time format. Okay, we get rid of that because we have one argument to it. And let's terminate the test again. I have a syntax error. Okay, not a syntax error, a type error. Oh, right, okay, so run. Now this either text or value, okay, that's okay. So evaluating the expression returns an eval result, and the eval result is not the value, it's not going to be okay or error. And okay. So this is going to take a value anymore, it's going to take a result. And this should be okay void. So previously successful. Seems weird to be OK. No, it's not weird to be OK in void. So if this is OK and X, then we call that. And then if we see call the function args and previous an error of X, let me just undefine that for a second. Okay, so now run should return, they should return a result, which means result itself, I've lost result because the file is too long. Result out to derive deriving stock. I will just do stock show and equal for now. Next error. Okay, we don't really care about these so much. Okay, so now we're not returning a time value itself, but returning OK time value. We're trying to export, so up here we will export value, but we'll also export results. Then we should be able to import this. Okay. And this should be right of OK and that. No. Let me go back to that 1 second. Okay. Down here it's the same thing. So you should be right of OK. Now. Okay, so forewarning, there's one error. And the error is just in this file, it doesn't understand. So in theory, apart from my undefined, so it should stop because of undefined, we should be okay. I might just write the test case and implement this immediately because it's actually quite straightforward. So we said errors can be returned from functions, and then also it stops processing the pipeline. No, we want a pipeline that works. No, we don't. We want a pipeline that doesn't work. So we'll call the same thing again. This won't compile because it's got a type error, so it'll never run it. So I think I want to add another function. Okay, so I just want to test the current handling in isolation. So let's just say call built-in function args of x. Takes value x. Okay, this is not the right implementation of the error case, but it should let me run the tests. And it does not work. So I expect to get, oh yes, it's not left, it's not an error from the interpreter. The interpreter is successful, but the function inside the interpreter returns an error. Easy to follow. So write error of this. Okay, that passes. So now we can look at the case where we return an error in the first step or somewhere earlier in the pipeline, and then the subsequent steps should not run. So for that, I think I want another command, which I'm going to call it handles format time. So we'll write the inverse of parse time. So we're going to, wow, this is quite a difficult to call. What does the time value look like? It's time height. Just jump to the definition of that. Oh no, time value. Okay, it does take a local time. So format time. Oh, I can see it's a local time because we're checking it line above. Right. So if I call format time, but the argument is not a string in this case, it's expected time. So we just call this t rather than expected time. It's going to take two arguments. First thing to take two arguments, so we'll take the format string and then the time. But that doesn't work because I've set the arguments list of texts. So I can't evaluate this on its own, can I? Because if you call it eval, yeah, it treats it as a whole pipeline. It doesn't call the individual case, the individual function. So I can't use eval like this. So let me just write it down here. Oh, where am I going to write it? These are individual functions. Not super useful. This is run. So maybe we'll just say it's, I don't know, works with times. I feel that it belongs in commands, but I actually want to call run. But maybe that's okay. So it handles format time. Because we know from the test above is that parse time works properly. So we run this. And we pipe the result into format time. And this will take an argument and we'll say YY MMDD. Put more Y's in there, because why not? And we expect this to be, what's the time here? So this is 2023-04-13. Okay, so this should blow up now because we haven't written format time at all. It should be a unrecognized function. Cool. So in our list of functions, we can say format time, and this is a function which goes from time to text, and it's going to be eval format time. So eval format time has got the function signature and eval format time of some argument x. and some time value v. It's got t. No, we always call the values v. This is going to be pure of case format time. That function. Look at that. So it goes from show me the whole thing. It's not going to show me the whole thing. I want the whole doc string. Case format time. I don't know what this is. Of. So we should have, I guess, is it going to be a maybe type again? Might not be. In the failure case, so we're going to say error calling format time. Don't know what the error is yet, but given just some output string, this is going to be okay text value of that string. And then we have this case again. And here should be format. Okay, so import data time format time. And the type of format time, there we go now, telling me. So we take a time locale, we take a string, we take a time, and return a string. And is there a format local time? No. Okay. So we need the locale. Can't remember how we get that. Then we need a string, which is x. We need a time, which is v. What time takes? Time locale and a string. Okay, this is a text, so this needs to be t.unpack. Okay. And it doesn't return a maybe type. Interesting. It just returns a string. Okay. In which case it's just going to be pure of okay of this. I'm really curious as to why this doesn't return an error, but there we go. Okay of that. Pure of okay of text byte, text value, sorry, of that. All right. Not pure. Yes, pure. What are we doing? No, it's pure. It is that. It's pure of okay of text value of this thing. Okay, so it needs to be text value of t.pack. Let's not do that in the middle of a chain of dollars. Right, we just need to worry about this locale. It needs to be time locale, and there's some default for this, which is something like default locale, default time locale. Okay, so we can try running that, see if it works. It did not work. Wow, just gives you a text back. That's interesting. So in the failure case, it just returns the input string. Right, now we did docs format time. So it's going to be percent y, I guess. Is percent capital Y going to give me 4 things? Y, year, no padding, pad 4 characters. So percent Y, percent M, percent D, I'm guessing. So percent, no, where's percent? There we go. Percent Y, percent M, percent D. Let's see if that works. Yep, that does work. Okay, cool. Okay, so we now have format time, which means I now have the functions I need. So I've got parse time, which can return an error, and format time, which would work if you call it. So instead of saying it handles format time, we can say it, oops, what does it do? It stops processing the pipeline. So here we're going to feed it nonsense instead. And it should be this thing. So I'm hoping by a horrible thing it's going to try and call format time. Well, not a horrible feeling. That's why I've written it, but that's what I expect. So we go, one rows calling format time, expected 1 but got 1. That's really interesting. It's actually the wrong error. So what happens now is it gets passed to text arg rather than a time arg, because I implemented this of just converting the error into text value and passing it along the pipe, which is not what I want to do. So the result of the error, so basically it was not okay, so this is the error, just be, I think, pure E. So calling it, I might make this a bit clearer, so it's E at error, and then whatever the error is, we don't care what it is. Okay, we can't call it E, so we'll call it error. Okay, I don't need to do this destructuring, but I think it makes it clearer what's going on. So now we can run the test. And look at that. We now have result types in the pipeline by default. So we've got functions which can throw errors or return errors, whatever. And we can safely continue along the pipe. And it just returns the first error it encounters, which is cool. So maybe next time I might look at adding another function, not another function, another operator, which instead of passing in the value inside the result, passes in the full result. So I could have a function which inspects whether or not the previous result was successful. That's what I'm thinking of doing. Cool. All right. Thanks for watching along. Thank you for the hint about using function signature. Much neater. Yeah. And next week we'll continue building something interesting. All right. Thanks for watching. Goodbye.